Hello, everybody. I'm presenting this work on R packages for movement, which is actually a review that I released maybe some months ago. And I'm doing a summary of this. So if you want to get the preprint, you can write me an email or a personal message on Twitter. You have them there. As was mentioned in the presentation just before, there is a lot of data available on movement on different kinds of individuals, such as humans or animals, with different types of tracking devices as well. And there are several tracking packages, so packages that have been created to process or analyze tracking data in R. And the trend is increasing, the trend of the number of packages developed in time. So I'm going to talk about what exists here in R to process and analyze tracking data. There are 59 packages. I did my review and counted packages until March 2018. So there are some packages I will not mention, and I'm not going to talk about all of the details of each one of them because I only have 15 minutes, and the only way to do that would be to rap about it, and I don't do that kind of music. This is what I call a tracking workflow, which shows different stages for tracking data, processing, and analysis. So first, tracking data. Tracking data is data that represents movement in two components, so the spatial and the temporal component. And in terms of spatial components, they are generally characterized in 2D, but there are some in 3D. There is what I call raw data that is not necessarily tracking data as I just defined. And to pass from raw data to tracking data, there are some packages that do pre-processing. Once we have tracking data, there are some packages that do some cleaning and formatting in order to use the data for analysis, and that's post-processing. And then in terms of analysis, there are different kinds, such as visualization, track description, path reconstruction, behavioral pattern identification, space use, trajectory simulation, and other types of analysis. And what you can see here, the numbers, are the number of packages doing each task, and some packages are doing more than one. I'm going to start talking about pre-processing, so it's passing from raw data to tracking data. And I'm giving one example. One type of tracking device that is used a lot, mostly for bird and fish data, are light level geolocators. So these things that we can see here on the bird are small, cheap, light, and they save a lot of battery, and that's why people use it. But what they only get is light level and not really like GPS data that we're familiar with. So light level series can give some information, like if we have information on light duration, we can have some proxy of day length and then get a proxy of latitude. And if we have also light intensity during the day, that gives information on solar noon, which gives a proxy on longitude. And there are several methods that exist and have been published and are continuously improved to pass from light level information to longitude and latitude. And these are the list of packages that work that do pre-processing. So GeoLight, ProbGLS, FlightR, Trackit, Trip Estimation, ISGAT, Twilight Free do pre-processing for GeoLight data. There is also pre-processing for radio data with telemeter and something called dead reckoning for accelerometer, gyroscope, and magnetometer data with animal track and track reconstruction. We can talk about the details later if you want. So that's pre-processing. You use data that is not really tracking data, and you transform it into tracking data. Then we have post-processing. Things like cleaning, when you have some, let's say, outliers, or compression, which is what sometimes is called resampling, like lowering the resolution of your data, getting less points in the end. And there are several packages that use different algorithms to do both things. And now we go to analysis. I'm just going to talk quickly about some of these tasks: path reconstruction, behavioral pattern identification, and space use. So path reconstruction. Sometimes we already have the tracking data, and we want to use a model on movement that will allow us to correct for errors, get finer data resolution, and get regular time steps. Sometimes regular time steps are important for other kinds of analysis. And there are several ways to do that. So in this graph, path reconstruction is basically get a model to only reconstruct the path based on the red points that we see. And there are several methods to do that. Again, you just have to remember that every single method, every single model means underlying assumptions that we have to understand to choose. So these are the list of packages. Again, we can talk about it later. Another important thing in trajectory analysis is behavioral pattern identification. So it means that we are not only interested in reconstructing the path, but also using the information from the observed movement patterns to get some proxy of behaviors. So in this case, we have, like, in this graph, the blue behavior that represents foraging, and the red behavior that would represent migration. Again, several methods exist, several packages, but modeling means assumptions. And there's also space use. Sometimes we want to evaluate the use of space by one individual or several individuals, and there are many techniques to do that that take into account movement. Some others are more about positions and static methods. Many packages available for that, some of them with very original approaches, some of them repeat each other. And now that I have very briefly presented what the packages are about, I want to discuss something that I think is very important, which is quality of a package. At the beginning of this presentation, I showed the increasing trend of the number of packages being developed. I think that there will be more to come, and more methods as well. But I think that even though this is a good thing, we should also think about how important it is to make a good package that can be useful for the community. And I wanted to point out that, and encourage developers to pass through rOpenSci, which is a platform for software peer review. And they have their own ebook. They talk about development, maintenance, and peer review. They encourage reviewers to evaluate packages based on usability, so how useful is the package, how easy it is to use, quality of the package, the styling of the code, and basically the documentation that is available for the package. I wanted to talk about that too, because I think that it is very important not only to have documentation on what each function does, on like the arguments that we have to use and the outputs, but also how do the functions work, what is behind, why they are important. And rOpenSci also mentions a statement of need, which is basically thinking about if the package is filling a gap, or if there's something, if the package is already doing something that exists, how is it improving it? I wanted to point out that I did a survey, mostly on Twitter, also passed it through some email lists for our users about the R movement packages, and 225 users completed the survey. There were 4 or 5 questions, but one of them was about how good the documentation of the packages, the tracking packages that I presented, were. And this is some of the results. So on the x-axis, there's the number of respondents, and on the y-axis is the percentage of users that said that the documentation of the package was either good or excellent. I'm only showing the ones that have at least more than 10 respondents. 11 packages showed over 75% of good or excellent documentation, so not every package. And if you're wondering about different colors, the purple one are packages that have standard documentation, vignettes, and papers. The blue ones are standard documentation and vignettes, and the green one, just the standard documentation that you use when you put help on the package. I think that documentation is really key for people to use the package and know actually what they're doing when they use it. And another thing that I tried to see was the connection between the packages. Because so R is free, we can do whatever we want with it, but we're also a community of users and programmers. And if there are some similarities in the things that we're doing, and if we are actually also using things that already exist, are we really working together? Are we really using what already exists from other packages? So this is a graphical representation, a network graph, and we see the names of the packages, the tracking packages. The solid lines represent dependencies, so what you find in the information of the package in terms of dependency, import, and linking to. And the dashed lines are suggestions. Packages can suggest other packages. And we see that a third of the packages work in isolation from other movement packages. Some of them really do different things. Some others do the same thing, and they're not really using what already existed. So I would say that I have 3 messages from this presentation. One is there are a lot of packages doing many, many things, so we should check them out and we should use them. That's a great opportunity. The second one is that if we really want to develop things that are useful for other people, we should really think about how what we're doing represents an actual contribution and to try to make it really useful for others. Useful not only in terms of how easy it is to use, how to maintain the package and so on, but also to present the methods, to present what people should be careful about when to use something. And the third one is for the users as well. We have a lot of packages, we have a lot of help in Google and different forums, but we have to be careful as well on what we're using. So there are many, many tools available, and we should not use something and then publish the results only because they are available, only because we can. We should publish something, we should do things that we understand. And there is a responsibility on the side of the developers, but there's also a responsibility on the side of the users. That's it. Thank you very much.
Thank you so much. I think those are great guidelines for people looking to try out a few new packages. I know I will be after this talk. So questions, and I'm not going to repeat them. I think you can probably hear them.
Hey, thanks for a great talk. Just a quick question. Are you an active user of any of those packages, and how do you think that may have had an impact on how you did it, and do you take any measures to deal with that?
When I started the review, honestly, I was only an active user of 2 packages, and I knew that there were a lot of packages. I didn't know how many. Now I know a lot of them, and that's when, by using them and trying to understand them, I got into difficulties of how do I know what they're doing? Like the method, some of them, vignettes were great, their documentation, papers that were comparing what a package was doing related to another one. That was great. Like the ProfGLS paper compares to another one for other ones for pre-processing, that's great. But there were other packages where I had to figure out with a lot of effort what they were actually doing. Some of them, the package was ready even before the method paper or the documentation was ready. And some people were already citing those packages in papers, scientific papers. So I think that the review has opened my eyes in different ways as well. And that's something that I wanted to share with everybody.